Now let's move on to currents and how currents behave in series and parallel circuits. Let's start with the meaning of the total current, or you could call it the current through the power source. Sometimes it's called total current, which is the current entering and leaving the power source, like the battery. For example, 2 gallons per second right here is leaving this pump right here. That could be termed the total current. So this doesn't get bound with air. We also need 2 gallons per second going in like that, 2 gallons per second of water going in. And it's important to understand that these pipes are completely filled with water, just like wires are completely filled with what? Well, with electrons. Every single one of the atoms in the wire has its full complement of electrons, otherwise it's electrostatically charged. Things don't like to be electrostatically charged. The charge of a wire in a circuit is 0. So we've got this 2 gallons per second coming out of this pump right here, and my question to you, the first question is this. 2 gallons per second is going into this end right here. How much is coming out there? Would you say that it is, choice 1 is less than 2 gallons per second? Choice 2 is the same as 2 gallons per second. Choice 3, greater than 2 gallons per second. How much is coming out here? This is a gravel-filled pipe, mind you. It's resistive. There's friction in there, and the current going through there basically creates thermal energy. It heats up because of friction, just like a resistor heats up when current's going through it. But let's get back to our question. Is it less than 2 gallons per second? Is it equal to 2 gallons per second? Or is it more than 2 gallons per second? Now, a very common misunderstanding is that people think, oh, there's resistance, maybe less is coming out there. That cannot happen. Every electron that goes in there, every electron, you put 1 electron in there, 1 has got to come out that end. Otherwise, you would be charging, or you'd be compressing water in there. Think about, water's not compressible. If you had 1 gallon going in there and only half a gallon coming out of there, what happened to the extra half a gallon? Here's a really cool demo that will help you understand this. What I've got here is a tube that's completely filled with marbles, just like a wire is already completely filled with electrons. And if I add 1 marble to this end right here, watch what happens at the other end. Hey, 1 marble comes out. If I add another marble to this end, 1 marble comes out of that end. So you can see that you cannot have more going in one end of this than coming out the other end. Water cannot be compressed, neither can electrons. So we know that if 2 gallons per second is going in this end, there must be 2 gallons per second coming out of that end. So we can see that regardless of the size or resistance, if a gallon goes in one end, a gallon's got to come out. In this case, 2 gallons going in there every second, 2 gallons have to come out of there every second. And that means 2 gallons per second have to go in here. What's coming out of this one? 2 gallons per second. It's coming out of here. And going back in there is 2 gallons per second. And that's how much is actually going back in there. Now, you may say, but if there's more resistance, wouldn't there be less flow? Well, if you added more resistance here, for example, by making this one narrower, there would be less flow everywhere in the circuit. So more resistance would mean less flow, but in series circuits, the current is the same everywhere. It's gotta be. If you got 1 marble going in this end and it's filled with marbles, 1 marble's got to go out the other end. There's nowhere else it can go. In a similar fashion, here's my electric circuit. I've got a 32 volt battery here. If I've got the total current coming out of the battery is 2 amps, what's the current right here? It's got to be 2 amperes, 2 coulombs per second. What's got to be going through there? 2 amperes. What's got to be coming back in here and going back into the battery? 2 amperes. In other words, the current through each resistor wired in series is always the same value for each one. I through R1, well, that's 2 amperes. I through R2, 2 amperes. I through R3, it's 2 amperes. The current is the same amount everywhere in a series circuit. Now you might ask, how did I get that 2 amperes? Well, to find I total, all you have to do is divide V total, which is 32 volts, divided by R total. R total is just 8 ohms plus 3 ohms plus 5 ohms, and here it is, and that's how you get 2 amps.